Tom, there's just some black lines across the top of the screen. I'm not really sure.
Well, good morning, ladies and gentlemen, and welcome to this BOFIN webinar on the very latest developments in satellite technology. My name's Tom Mannon-Stevens. I lead the British On-Farm Innovation Network, and we're going to be delving today into the exciting world of hyperspectral monitoring. More on that in a minute, but first I want to bring you up to speed with what else is coming up with BOFIN. So I'm just going to share my screen. So we've completed the first year trials for 3 major DEFRA-funded projects, and we're already underway with the second year on the NCS project in Pulses, exploring the truth behind improving soil and root health and developing strategies to tackle slugs in slimers. We now have 18 Pulse Pioneers, 20 Root Rangers and 30 Slug Sleuths being paid to carry out trials. It's quite possibly the biggest set of farmer-led trials ever undertaken in the UK. And we're looking for more Pulse Pioneers to join them and help understand how we can make the most of peas and beans. And there's more. We've now launched Probity, a project bringing precision-bred crops to commercial farms for the first time anywhere in Europe. But we need your views on this advance in crop technology. So please take the Probity pledge. Spend at least an hour finding out about gene editing, and then bring your thoughts to the Sequence Circle and help shape the crops of the future. We'll also be launching our Innovation in Action Open Days this year, supporting our trialist farmers to host an event or farm walk so other farmers can see the trial they're undertaking and hear how they're getting on. So look out for a number of events that we're also going to be attending this year, like cereals and groundswell, for example. And also look out for the trials results. Our farmers did a sterling job amassing a plethora of readings, observations and photos from the plots last year. You'll be able to hear first about the results and conclusions as the scientists we work with sift through the data. And as if that wasn't enough innovation bursting from our fields in 2025, the Adopt Fund was recently relaunched by DEFRA Secretary of State Steve Reed at the Oxford Farming Conference earlier this month. Now, details are set to emerge later this spring, but we understand it's £40 million. Yes, £40 million for farmer-led trials. So bring your ideas to us and we'll help you turn them into in-field innovations. So how do you find out about all of this? Well, make sure you're signed up to one of our BOFIN communities, or all of them even. It's free and there's no obligation. And then join the conversation in the Soil or Slug Circle or Pulse Pet, our forums, in the Knowledge in Farming section of the Farming Forum, where we now have our newest forum, of course, the Sequence Circle, with resources and discussion on precision-bred crops. So please sign up to that one and give your views on gene editing. That's part of our Probity pledge. And of course, there's the BOFIN Buzz, the podcast that delves into the wondrous world of science and technology in agriculture, and a host of videos on our YouTube channel. And it's another jaw-dropping new technology that's brought us together today. So hyperspectral monitoring, what is it? Well, thanks to Messium, who are very kindly supporting this webinar, we'll find out, and more specifically from George Marangos-Gilks, who I'll introduce in a second. Then we'll hear from Pete Berry at ADAS, who'll look at the science of optimum fertilization. George will tell us a bit more about the technology and the trials they've been undertaking, and we'll be joined by Suffolk farmer and ag innovator Tom Dewars on how he gets on with satellite tech. Then George will fill us in on the pilot trials, and we'll move into an open discussion with all of our speakers, which is your chance to have your questions answered. So please do put these down in the Q&A, which you'll find at the bottom of the screen. Now, before I introduce George, we'll just run a quick poll to determine where we're already getting some results on the poll to determine how much you know about hyperspectral monitoring. I have to say I'm looking forward to learning quite a lot about this. So if you'd like to put in your votes, we're already getting quite a few, and it looks as though, yep, there's not a lot of knowledge out there. Well, we're hoping to turn that around. So I'm going to end the poll there, I think. And yeah, let's just see if we can bring that up there. There we go. So, yep, there's not an awful lot of knowledge out there about hyperspectral monitoring. It's roughly half and half between either basic knowledge and I know nothing about it. We've got just one or two people who've either used it or come across it before. So, fantastic. Well, without further ado then, I shall stop sharing my screen and I'll ask George Marangos Gilks to join us. George, take it away.
Thank you, Tom, for that warm introduction. Hi, everyone. I'm George, one of the founders of Messium. Let me just present my screen. Great. I hope everybody can see that. So Messium, we're using, as we are all here today, this new type of hyperspectral satellite. I'm going to give a quick intro to the company, and then we'll talk about what's new with the hyperspectral satellite. So our name comes from an old constellation, the Harvest Protector constellation. It's called Kustos Messium, and we thought that was quite appropriate for a satellite company that's trying to do good in agriculture. And that really is our ethos. We are here to do good and deliver value. If we can't continue to deliver value, we will stop doing what we're doing. We will never be perfect. Agriculture is quite complex. There are lots of variables, but we always want to understand what has changed, what we quite potentially didn't get right, and make sure we improve that. And I think with an ethos like that, hopefully we then get very good continual progress. We're backed by the UK Space Agency, the European Space Agency, and UK Innovate, as well as private investors. We've got a team of 8 at the moment, which is expanding. They're all phenomenal technologists and operators. Briefly on myself, so Messium is my third company. I've had a couple of successful startups before this, and I'm very excited about what we can do in agriculture. I met Vishal at a climate networking event, so we're both passionate about doing something positive for the planet. And Vishal previously had a satellite business predicting forest fires, so he's very experienced in the satellite technology side of things. So now, the transformational power of hyperspectral technology, it really is very promising and exciting. A quick history: NASA launched the first hyperspectral satellite about 10 years ago. That was continuing from advances with the imaging technology on the ground. The satellites were very large. They cost billions of dollars to launch, and it took a long time to get the data down from these satellites. They were primarily research satellites. Last year in 2024, the first commercial constellations launched. So thanks to SpaceX and Elon Musk, whether you like him or not, he has done some amazing things for space. We can now launch much cheaper, much more powerful satellites. And so there's this new age coming with richer data. We're working with 7 satellite companies this year, 15 satellites. That number is more than doubling every year. So there's a lot of satellites that are being launched. To talk then about how hyperspectral works in simple terms, the visible image that we see has 3 wavelengths in it. It's red, green, and blue light. A hyperspectral image moves into the invisible spectrum, into infrared, but every chemical on Earth will absorb and reflect a wavelength, and it has a spectral signature. It's basically an invisible color that we can see. So the wavelength reflected for gold is slightly different to the wavelength and the squiggle of the line for lithium as it is for nitrogen. So we can see the nitrogen in the crop. It's not the nitrogen directly, it's the elements around nitrogen. So the photosynthesis that's taking place, the proteins and those elements. It's been well established in the research using hyperspectral cameras on the ground with drones and planes. There are key nitrogen wavelengths that we can see. They're about 5 nanometers wide. We take these wavelengths and then we have a very good understanding of the amount and the intensity of the nitrogen in the crop. This is a rather complicated image of how the wavelengths are processed into a hypercube and then how we can see the nitrogen. The key thing that I want to kind of ram home here is that hyperspectral satellites are the first satellites ever to be able to see nitrogen. Previous generation satellites, if you've ever used an NDVI product, they are very good at understanding biomass. They're good at understanding different levels of green density in the crop. They can show you where the biomass is larger or smaller, but they can't tell you if that biomass has high or low nitrogen. So this is the big revolution. We're linking biomass and nitrogen insights together to then apply the science. And that's what Pete is going to talk about, the nitrogen dilution curve effectively. We get accurate weekly data to understand both biomass and nitrogen. Just finally then on how we collect our samples. So we've collected over 14,000 samples globally. A sample is a 50 centimeter row of crop. Every sample has a GPS pin dropped at that location. We send this off to a laboratory. They will tell us with high accuracy both the nitrogen concentration and the biomass. We take this data, we link it to the GPS location, and then we match that to the satellite image that has been acquired at the same time. The more times we link this information together, the more powerful our AI and predictive model becomes. And the goal, the goal is to completely remove the need for a time-consuming and expensive lab test. We really think that hyperspectral can be 90% as accurate as a lab test. This has already been proven in research with high-altitude drones and planes, so we're recreating it with satellites. The model is already 84% accurate, and we think it will be 90% accurate this time next year. Over to you, Pete, to talk about the existing science.
Great, thank you very much, George. Yeah, so I'll ask Pete to join us. Thank you very much. And you'll be looking at, if you could unshare your screen, George. Pete, if you'd like to, thank you very much for joining us, Pete. If you'd like to bring up your slides, thank you.
Thank you very much, Tom and George. Good morning, everybody. I'm Pete Berry from ADAS. I'm a crop physiologist. I'm going to give you a whistle-top tour of the science of nitrogen requirement in wheat. There's lots of work being done over the last few decades, really, of understanding nitrogen requirements in wheat. And we know the main steps, which is for the crop to take up the nitrogen, and the crop uses this to build green area index, or GAI as it's often abbreviated to. And the green area index then intercepts the light. The light drives the photosynthesis, which then enables the crop to build biomass. So that's the sort of basic steps. And all the research which has been done in the last few decades has enabled us to really understand each of the steps within that process. So, for example, we know that when the wheat crop is growing well during stem extension, then it's taken up about 3 kilograms of nitrogen per hectare per day. So it's really taken up the nitrogen pretty fast. And then it takes up that nitrogen to build the canopy, and each unit of green area index contains about 30 kilograms of N per hectare. So we know how much nitrogen the canopy needs to take up to build its canopy. And then we understand the relationship between the size of the canopy and the light interception. It's a law of diminishing returns. There's no point in producing an absolutely massive canopy because you're not going to intercept any more light. But you do need to sort of reach that sweet spot, that optimum size of canopy to intercept most of the light. And then we know that for every megajoule of light or photosynthetically active radiation that the crop intercepts, the crop's able to produce about 3 grams per meter squared of biomass. So we know that relationship too. So we know a lot about all these steps, and you can actually sort of do some complicated maths, which uses information about the cost of nitrogen and the value of the yield to work out how much nitrogen you should optimally apply, and what optimum size canopy you need to get the most margin from the nitrogen that's applied. So we understand this pretty well. However, the season and conditions don't always play ball, do they? So sometimes we find that unexpectedly the crop hasn't been able to take up as much nitrogen as we expected. It might be because the nitrogen's been immobilized in the soil. Perhaps there's been a lot of straw incorporated, which has immobilized the nitrogen, or perhaps there's been a big flush of nitrogen because weather conditions and soil conditions have been warmer than expected. So sometimes we find that our crops have either not taken up as much as we expected, or they've taken up more than we expected. And it's in these situations where we have to start to adjust our nitrogen rates within the season to take account of these changes. And there's various ways of doing this. I'm going to describe the way that forms the basis of the Messium approach. And this is really based on the critical nitrogen concentration within the crop. And this is described by this relationship here. And this relationship is based on wheat. It's from many trials, in many different regions, which show that there's a critical nitrogen concentration in the crop biomass. If you're above this line, the crop has basically taken up too much nitrogen, more than it needs, really. If you're below this line, the crop has taken up less nitrogen. It's had an inadequate nitrogen supply. And you find that depending on the size of the biomass, there's a different critical nitrogen concentration. So this line is the critical nitrogen concentration. The bigger the biomass, the lower the critical nitrogen concentration. And that's because the bigger the biomass, the more stem there is in the crop. And stems, for example, structural tissues have a lower nitrogen concentration compared with leaves. So early in the season, you might have a crop biomass which is about 3 tons per hectare around early stem extension. Most of that's leaf. So leaves have a high nitrogen concentration, and the critical nitrogen concentration for that type of crop will be about 3%. So we could use this as a basis for checking whether our crop is had too much or too little nitrogen. And this forms the basis of something called a nitrogen nutrition index. It's a commonly used term in the science, and it's used to estimate whether the crop biomass nitrogen concentration is adequate or not. And what's used is what we call a nitrogen nutrition index, which is the ratio between the actual crop N uptake and the critical N uptake, which is described in this curve here. And basically, if you're less than about 0.9, it indicates inadequate N uptake. And this sort of system forms the basis of various fertiliser systems. For example, there's systems in France which use this approach. And it allows the opportunity to be able to sense the crop to check whether it has sufficient nitrogen concentration in it, whether the NNI, the nitrogen nutrition index, is less than the critical amount. And there's other research papers which have shown that it can be remotely sensed to test whether your wheat crop has got a low or a high NNI. So hopefully this is a good sort of introduction to George's technology and the trials which he's been doing to test this technology in the next few slides. So thank you. I shall stop sharing, and yeah, if you do think of any questions, I'm happy to answer them in the chat or later on in our discussion.
No, brilliant. Well, thank you very much for that, Pete. That's really good introduction background there. Yeah, I'll hand back to George to take on. As Pete said, do carry on putting we've already got some questions popping up in the Q&A, which we'll address at the end. So please do keep your questions coming, and we'll put those to the experts at the end. But I'll hand back over to George. Thanks.
Thank you, Pete, for that overview. And I should also say thank you for the countless hours you have given us in video calls and over email. You're very much the godfather of Messium's technology. And so we're, obviously very grateful to have your input and your guidance when we're building this. Vishal is in particular the expert on the remote sensing and the hyperspectral side. And if we can bring that and apply the crop growth models, it's I think, a good framework to be able to apply the science effectively mid-season. So let's look at some of the legacy solutions and their limitations. First of all, we've got lab tests. Lab tests are very accurate. They can tell us with high accuracy both the biomass and the nitrogen concentration of the crop. Of course, lab tests are very time consuming and expensive. I wish we had an army of garden gnomes and an unlimited budget so we could test every field on a weekly basis, but it's simply impossible. Handheld sensors are similar. They're not quite as accurate as a lab test, but we all know how time consuming they are, and they're simply just not practical to do on a weekly or every 2 weeks. So moving on then, the obvious solution, if we're thinking about scale, is satellites. With a satellite, you can image an entire farm. You can do it quite regularly. And if the data was good, then that would be a fantastic solution. The problem with existing or previous generation satellites is that NDVI simply doesn't do nitrogen. It's very good at doing biomass, showing you the different areas of green density, but you can have high biomass and low nitrogen. You can have high biomass and high nitrogen in the crop. So it doesn't tell you whether you're above or below that nitrogen nutrition index, the critical nitrogen dilution curve. And that's really the key to utilizing the science effectively. Quickly then, while we're on satellites, I should mention that cloud cover is obviously an issue with NDVI. There are only 2 Sentinel satellites. These come over about every 10 days. So it's very easy to have a cloudy image, and then another cloudy image. With hyperspectral satellites, there are 15 satellites we'll be working with next year. There is basically a satellite overhead every single day. So the chances of having a cloud-free day in a 2-week period in the UK is about 96%. And the number of satellites are doubling into 2026. And so there's no issue with cloud. Of course, cloud is always a challenge. If you have cloud for 2 weeks, then we can't do much about that, but we should be able to capture images on the cloud-free days. Moving on then, so hyperspectral drones, potentially these are the answer. The problem with drones is that they're very large and expensive. So here we can see Tristan. We actually took some drone images last year. We wanted to compare them to satellite imagery. That drone costs about £400,000. The insurance is ridiculous. Drones have all sorts of calibration issues with moving around with the wind, sun and clouds in the background change too much. And also they capture far too granular data. The amount of data captured from this drone was so large, we couldn't send it over the internet. We had to send a physical hard drive with the data in, and it's simply too much. It's overload. So drones, while the hyperspectral cameras themselves are very accurate, they just don't scale in the same way as a satellite. Tractor sensors, so these are interesting. If you look at a tractor sensor, they look at 5 wavelengths, so slightly beyond the visible image. Hyperspectral sensors go up to 450 wavelengths. They capture far more of the important nitrogen wavelengths, so they are more powerful and more accurate. But actually, the big problem with tractor sensors is they don't do timing well. The tractor sensor is only making a fertilizer recommendation when they drive over your crop. You could be 2 weeks too late. The crop could have been deficient for 2 weeks, in which case the growth was stunted, or you could be 2 weeks too early, in which case you're applying nitrogen when the crop already has absorbed a lot of nitrogen, it's saturated, and therefore it's less able to take it up. I'll talk about this a bit more later. So in summary, we think that Messium is the first and complete solution. We're excited to piece all of the different bits together and really try and bring that holistic picture. Moving on, so I'm going to talk about some trial results that we have seen in 2024. So the first thing to say is that we sampled over 47 farms across Europe. We collected over 1,000 samples. This is partly to build the satellite model, but also we were interested in what was happening in season. The results are that 51% of fields were over-fertilized. They were 40% above that critical nitrogen dilution curve that Pete showed at different stages in the season. So on average, they were 40% above. 39% of fields were under-fertilized by an average of 28%. It's a very big error either side, obviously with a slight tendency to the over-fertilization to avoid deficiency, which is understandable. This makes sense. It is very difficult to understand the nitrogen concentration of your crop mid-season, and hopefully, given how large the error is, we think Messium can drive benefit. In fact, we showed this benefit in the UK. So we worked with 14 trial farmers, 10 of them saw benefit. 3, we helped reduce nitrogen for the third application and sometimes in the second application when we saw the crop had luxury. For 4 farmers, because the majority of our farmers demonstration and quite rightly trying to apply less nitrogen, we helped them apply a little bit more and boost yields. And then with 3 farmers, we actually noticed that nitrogen was not the rate limiting factor. Plenty of nitrogen had gone down. The crop was not responding and it wasn't increasing in biomass. This indicates potentially a PK, manganese or calcium issue. Often you will have a very good idea of what that is. If Messium can help signpost that early and that micro or macronutrient deficiency can be corrected, then we can get the season back on track. So here's an example of a farmer we worked with. The Messium strip is down at the bottom in blue. It yielded 7.7 tons per hectare. The rest of the field yielded 5.2 tons per hectare. We applied 30 kilograms of nitrogen extra, a total of 160, so still way below the RB209 average. And obviously this is a result that we're pretty proud of. Of course, there is some natural variation that cuts across the field with potentially a bit higher yield towards the bottom part, but we still think nonetheless this is a pretty significant result. We have also done lots of recommendation trials in Australia and in New Zealand. We gave 27 different recommendations to farmers in Australia, and we worked with 5 farmers in New Zealand. 3 of our 5 farmers in New Zealand have each held the world record for the highest yield, so we really are working with the world's best farmers. We used a far more advanced crop growth model by the time, because we'd had a few months to build and improve the model. And we were far better at bringing the fields back in line with that optimum nitrogen nutrition index curve. So timing is something that we have seen in season is extremely important. I talked about this briefly with the tractor sensors. There are 2 ways that timing can be off. Firstly, you can be applying nitrogen when your crop has been deficient for a couple of weeks. That will severely hamper biomass growth and therefore future yields and profits. To avoid this, farmers often will go early. If in doubt, put more down. And that means that a lot of the time farmers are applying when the crop already has quite good nitrogen in it. It's got excess nitrogen, or we could call that saturated nitrogen. And here we have a really interesting example with Tom, who is going to speak later. So we had 8 different nitrogen treatments from very, very low all the way up to very, very high. The highest was 250 that we can see here. There were 2 farm standards, and Tom applied all of these strips at the same time. We looked at the data for the Messium strip and we saw that it had luxury nitrogen. So we asked Tom, can you please go and apply the nitrogen in the Messium strip, but do that 12 days later? So the Messium strip received 227 kilograms of nitrogen. There was a strip next door to it that received 225. So basically the same amounts of nitrogen. But the Messium strip yielded half a ton per hectare more. This is because when we applied, the crop wasn't as saturated with nitrogen. It was able to take up more of the nitrogen and therefore build more biomass and yields. I think really, really interesting result there. Now on to Tom.
Great, thank you very much for that, George. Yep, and Tom, delighted to see you here today. Good morning. And Tom, well, I mean, I have to say, I'm really excited about this technology. Well, what it's going to tell us about what's going on in our crops, and also, of course, it's the sort of technology that is absolutely ideal for on-farm trials. So, would you like to just start, Tom, by just giving us very briefly an introduction to yourself and your farm?
Yes, so Tom Dewars, I farm in the middle of Suffolk, family farm, all arable, about 900 acres that we farm. And yeah, I've been trying to reduce my nitrogen applications as much as possible to try and be more efficient, to attract some investment, shall we say, from third parties. So there's plenty of environmentally friendly money out there if we can do the right thing. So any technology that could potentially help my nitrogen use efficiency is on the radar. and this actually jumped out to us from the Climate Neutral Farms group that I'm involved in, which is part funded by Nestle. So I think George approached them, and then they were looking for some trial farms. So we gave it a go last year, and as George said, it was we had some interesting results.
Now, you've used satellite technology before, I think, haven't you, Tom? So what's different about this?
Yeah, well, that's been my endless frustration, to be perfectly honest. So I think we started using satellite imagery, NDVI imagery for nitrogen in about 2011, and then realised that if we couldn't get an even establishment for a start, then that was pointless. So we did variable rate seed to try and get a level playing field for a start, and then varied the nitrogen. But when we're purely looking at green versus not green, effectively biomass, we're really, the advice was always chuck more in on the low bits for a start, or the thin bits, and invariably they don't catch up, so you then put less on afterwards. And it was all a bit it never really seemed to be very scientific, or it's very difficult to measure a response in the first place because nitrogen's variable anyway. But it just seemed to me that it was the wrong advice potentially for what you were actually looking at. You were applying an element, and that wasn't necessarily the issue. The issue might have been slugs had eaten it all. So I moved away from doing satellite imagery actually, and I just started using yield maps, historic yield maps, combining them together and saying, well, that part of the field is always pretty low. We'll look at our N response curve and say, well, if we only get 7 tonne a hectare on that headland, we'll reduce the N on that and concentrate on putting the N on the middle of the field where we might get 11, and then hopefully we'll get a decent average. So we'd been doing that, and that's still my starting point for the year effectively, because for the last couple of years we've had very, very cloudy springs, and yeah, that was the first thing I said to George was, and I noticed there's already been a question about that, is what happens in the good old English countryside when we don't get any imagery. But hopefully with the amount of satellites that are coming on board, that is going to get better and better.
Yeah, and I think George has answered that to a certain extent, and exactly as you say, the number of satellites going up there is more. But I want to ask, specifically, so what the difference here, as far as I can see, is that you actually get feedback on exactly how much nitrogen is in the crop. Is that the data that you were working from then?
That's what we need, because we're now measuring or looking at what N is in the crop, and we know that nitrogen drives lush green growth, which then drives disease pressure. So especially here in the east, we suffer with very dry springs, apart from last year. So we've tended to start applying more and more N earlier, and the fact is that if we're above that that critical N curve, then it's not going to take that nitrogen up as efficiently because it's already got too much. So we're slapping it on and hoping it's going to get in there, but our use efficiency will go down. So the really interesting thing to me from this Messium thing was just that delay in the timing, because we had eight strips across the field from 100 kilos up to 250, as George said, and the 225 and the Messium strip being right next to each other, and seeing this sort of 0.6 of a tonne yield response from a place in the field where there isn't historic variation, with these two strips right next to each other, that was quite interesting to me. We don't often see that sort of response from a trial, so I'm quite excited by this. Obviously, it's only 1 year, so we have to take that into consideration. But we did some strips in other fields as well. Just basically, there you go, Messium. There's a sample. How much N should I put on? And last year was a low N min year, so there's less soil mineralized in the soil and N mineralized in the soil. So my farm standard approach, if you like, I hadn't ordered enough nitrogen for the year anyway, and stupidly didn't order any more. But Messium's came back and said, well, you need to put X amount on that field, and we saw a big yield response from the amount that we put on. So it's making us better informed, basically.
Yeah. So final questions. I can see we've got loads of questions coming through on the Q&A, so I don't want to rob time from that. But I just wanted to ask, when it comes to doing on-farm trials, it seems to me, Tom, that this is an ideal system to put through, your standard tramline trial type approach on farm. Would you have you got any views on that? I mean, I know that you've been doing lots of trials on your farm over the years. So, how did this the trial that you did here? Did you feel that you were taking the right approach to testing the technology?
Yes. I mean, it's always difficult on smaller plots. So we divided sort of 48 meters wide samples. But I think it'd be nicer to do it over a wider area, perhaps several split fields, for instance. But it's always difficult with in-field variation to get a feel for trial results. But I think anybody that's got variable rate capacity on their spreader and can just take a map, put it in their spreader and try it on half a field against their standard approach, and be careful not to be led when you say, right, I'm going to put my second dose of nitrogen on the first week of April, and Messium say, you know what, delay that for 2 weeks. You still need to go out and put your bit on first week of April, because that's what you were going to do, and not try and be swayed by, maybe I should delay it.
Right.
If you want to do a true trial, you've got to think, what would I have done to test it properly? But I mean, it's quite simple. If you can accept a ISO XML or a shapefile onto your machine, it's quite simple.
Great. Well, listen, I know that George, you wanted to come back and talk about the trials that you've been undertaking, but just quickly before you do, if I may, George, just wanted to point out that we have got, as I said earlier on, we're doing quite a few farm trials, on-farm trials as part of our projects. The NCS project in particular, the farmers who take part in that, we enter them into the yen, both in their pulse crop and then following that in their cereal crop. Yen is a great way to get some additional data from a farm trial and see exactly what it's doing. We'd like to explore with you, George, how we can work with you to perhaps get more data from our trials within this project. But that's probably a conversation for another day. I know that you wanted to present a few slides just to go through the pilot trials that you've been doing.
Thank you, Tom. Yes, we would love to explore that. The more data the more data, the better. And if trials are already ongoing, then it should be very easy to collect that. So quickly to talk about Messium's trials next year, we would like to split a field in half. So half as a Messium treatment, half as farm standard. We will send an independent sampling technician, to collect samples 3 times in the season. So 10 samples from the Messium side, 10 samples from the farm standard side. We have a lot of confidence in the satellite model, and we know it's very accurate, but because this is the first time we're doing larger scale trials, we also want to do the sampling alongside to make sure we have 2 very accurate data sources. So both satellite and lab data feeding in to the model. There will be no requirement for sampling in 2026 and onwards. So this is an exceptional one-off. We are arranging and paying for all of this sampling, and what we will do is provide then a nitrogen heat map of the farm. So we will show the nitrogen adequacy of the Messium side versus the farm standard side. We will give a recommendation for the Messium side, and what we ask in terms of participation is that, as Tom said, you're prepared to vary the nitrogen rates in the different strips, but you're also prepared to go into the field at different times. And I know that is a bit more of an ask. Hopefully you can see enough value in what Messium is trying to do that it's worthwhile. I should stress that that might not be the case for all farmers. It might only be 20 to 40% of farmers that would need to vary the timing. We shall see in season. The third ask is that you're willing to collect yield data at the end of the season, ideally on a combine, and grain protein as well. Messium is investing quite a lot into these trials. So the independent sampling 3 times in the season is quite expensive. So is the lab analysis at £20 per sample, and the satellite images are also quite expensive. So we ask a small contribution towards this of £650 if you're interested in being involved in the trial. It's also a good sense check for those people that really are bought in and invested. As a thank you, we're offering £1,000 future discount, and we're actually also guaranteeing to increase the net profitability of the Messium strip versus the farm standard strip by 7%. We will get the data at the end of the season. If we don't hit that 7% improvement, we will refund you, no questions asked. In fact, if you're unhappy with absolutely anything as part of the trial, any element of it, and you would like to ask for the refund, we will issue that. We are always about making sure we deliver value and that you know, the farmer that we care about most is happy. So that's the trial overview done. I think just after this webinar, a survey form will be sent around. I think it's got 6 questions, which will just help us qualify who could fit into the trial. Basically, we are satellites take very long and thin images, and we are trying to maximize farms within those images. So there's a bit of a selection process that goes on. But if you could please fill out that form if you're interested in being involved, and in the next kind of 10 days, we can tell you to go whether you're into the next stage. Hopefully you can see that the trial is quite straightforward and will deliver a lot of value. And ideally, if we can prove these things out this season, then that it can accelerate future value in future seasons. Thank you.
Great. No, well, thank you very much for that, George. And I'd like to ask if Tom and Pete could switch their cameras back on, turn on their audio, and yeah, and let's have a discussion. I can see that we've got some questions coming through, and there's some really great chat going on in the chat room as well. So it's great. You know, thank you very much for everyone who's participated in that. If you've got a question, please do put it through. But we've got one that came up. Well, a couple of questions actually from Eddie Barsley. So thank you very much for your contributions, Eddie. He's put 2 questions through actually, and I'll ask both of these together because they're related. But he's asked, is the hyperspectral technology directly measuring the wavelength specific to nitrogen, or is it measuring other things used as a proxy for nitrogen? And then another question he's put through is, do you think that the tech will eventually be expanded to measure other elements? I must admit, George, when you started your first presentation and you were talking about measuring gold in crops, I was thinking, oh wow, well, that would be great, wouldn't it? I don't think there's much gold in my crops, but yeah, would you like to just address Eddie's questions, please?
Pete, would you maybe like to take the hyperspectral one and what it's directly measuring in the wavelengths?
I don't know the answer to that one, George, I'm afraid.
Okay. That is probably one best for Vishal, my co-founder, but what I've understood is that there are lots of research papers out there that have established the relationship between the wavelengths we're measuring and the nitrogen in the crop. It's not the nitrogen directly, there are proxies for the nitrogen. So the amount of protein that we can see and the amount of the elements that are producing photosynthesis. Great. I can get back to you with more detail on that one from Vishal. The second question, so can the tech eventually be expanded to measure other elements? Yes, as part of our nutrient management grant this year, we will be collecting samples to try and see these other elements. So we're working with UK AgTech Centre and Hutchinson's. We have 7 farms where we will be looking for PK and then a host of the other micro and macronutrients.
Great. No, that's fantastic. So, I mean, Eddie, what we'll do is we'll pass your question back to George, and then George will come back to you directly with the answer on that one. But no, that's really so. So just to get things clear, George, I mean, obviously, you know, there are other elements like phosphate, potash, and so on, sulfur, perhaps. Are these the sorts of things that you believe that you'll be able to deliver some data on those in future years?
Yes, so there are already research papers that show these can be detected with hyperspectral drones and high altitude hyperspectral planes. It hasn't been done before with satellites. In fact, I think there are a couple of Prisma satellite papers that have shown this. And so we're making the jump to trying to do that with satellites.
Great. Well, actually, that brings us on to our next question. Thank you very much from David White. Very glad to see you here on the call, David. You know, what David doesn't know about precision technology isn't really worth knowing. But he's asked this question here. With timing and application accuracy being key in optimum yield generation, having got these recommendations, should we be applying nitrogen with full width boom spreaders and sprayers, not trying to throw a 3mm granule 36 meters? Is foliar product any better? And I don't know, Pete, I wonder whether this is one for you.
Yeah. I think the first thing to say is that the recommendations are more on a field basis initially. So, that's where the biggest gains will be. And work we've done with variable rate nitrogen has shown that it's the most important thing is to get the field average nitrogen rate correct. So focusing on that scale first is the priority, I would say. And then when you look at the sort of spatial variation that you get in things like soil residual nitrogen around the field, it can vary at quite a small scale. So, I don't think you can get around the fact that 36-meter boom width will end up, or spread width, drumline width, will end up sort of reaching across quite a variation in crop and soil. But and there is technology I know that you could use a sort of, if you're using liquid N, potentially you could sort of vary nozzles, but I think that's a bit way down the line yet. The question about using foliar N, I mean, there's an argument for using it rather than soil applied N, but you sort of avoid the nitrogen have to go in the soil, and the soil can lock it up potentially, and there's an inefficiency in that process, isn't there? But there's a limit to how much foliar N can be delivered into the plant. If you want to deliver 200 kilograms of N per hectare to the whole crop, foliar N could deliver part of that, but it will struggle to deliver a substantial amount of it.
Great. No, Tom, I'd like to bring you in here, if that's okay. So what's your experience? This idea of resolution, I guess, is what we're talking about here. I mean, obviously, the satellites themselves, the resolution of the data that you get back, as far as I'm aware, George, and correct me if I'm wrong, it's round about sort of 10 meters squared or something that you can get.
5 by 5 meters squared. So this year we will be doing variable rate. Last year, we were just doing flat rate for the field. As Pete said, we were aiming for getting the average rate right in the field. That's the first most important step.
Yeah. And I guess, that's the thing that, 5 by 5 meters squared, actually, when you're standing in a field, it doesn't sound like that's particularly high resolution. But then when you're applying fertilizer, that's, well, what's your experience, Tom? Is that, this resolution, and then addressing it as well, foliar nitrogen?
Well, yeah, I mean, when we were trying to get the small robot company up and running, we were trying to get as granular as a per plant, weren't we? But now we're back to where we are. It's an interesting point that David makes, and I've sort of gone backwards and forwards with this, because we're on granule. We do some foliar, but I haven't got a liquid kit on my sprayer. But actually, for this sort of thing now, I'm on 24 meters, but I can vary it over 12, and I couldn't do that with a boom spreader, because my fertilizer spreader will throw the left-hand side at a higher rate than the right-hand side if the map says that's what it needs to do. So it's actually slightly more accurate than my boom sprayer would be, because I can't put a higher rate on one side of the boom than the other. So it's all a bit, we win some, lose some at the moment, I think. But I think foliar. Well, my experience with foliar is that we're only putting quite small amounts on, and when if you're then trying to vary that, perhaps you've either got the risk of scorch on the bits that need a lot, or putting next to nothing on the other bits. So I suspect. I mean, we try and just top up foliar at the end, but you're only talking about sort of 7 kilo dose at a time, so it's not a massive amount. But I mean, like Pete says, we probably need to get there eventually, where we can vary the rate on a section of a sprayer, for instance, but it's not there yet, and if it is, it's probably very expensive.
Well, I mean, it has to be said, as you point out, spreader technology has really come on in recent years, and the accuracy of spreader technology is, I always think, quite staggering, considering it's just chucking these granules out. But anyway, I'm going to move on. There's a question that's come through about what the trial requires. So does George's trial require wheat, George?
Yes, please. We are focused solely on wheat at the moment. We want to do one thing very, very well.
Great, fantastic. I mean, presumably, once you've got some good data on this, you will be looking to other crops as well.
Correct. Yes, we would love to do barley in the future. It's a sister crop, so a lot of the learning should be quite transferable. Potentially looking at corn in the US and also disease, so septoria and yellow rust. There is some really interesting research to show that signs of septoria and yellow rust can be spotted 2 to 5 days before they're visible to the naked eye. So we're extremely excited about that.
Whoa, fantastic. This is really interesting. And of course, one crop that it's probably not going to be particularly useful for is peas and beans. And we've got Roger Vickers from PGRO on the call today. Thank you very much for joining us, Roger, and thank you for your question. So the question here is, can the data from the technology be used to evaluate crop development too? I suppose by this I mean crop biomass and maturity, as well as the end content. I probably said the wrong thing there, actually, Roger, that actually it would be really interesting to use this on peas and beans. But what are your thoughts on this? George first.
So we take the nitrogen, the biomass data, and then we use that to update a crop growth model. We use two leading models. We use DSAT and AppSim. You can think of that crop growth model as effectively a digital twin for the plant. We like to understand everything about the local environment. So the soil type, the sowing date, the seeding density, the wheat variety, the previous crop, the organic soil mineralization. So we try and build up the best picture possible of the crop's growth and evolution throughout the season. We want to understand the nitrogen concentration mid-season so that we can give the best recommendation for the next 2 to 4 weeks. But ultimately, the thing that we're doing throughout is we're understanding the evolution of the crop. So yes, we are forecasting that future biomass. We're forecasting actually the yield at the end of the season and the protein level. So those things are tricky to do, but that is all part of what we do.
Great. Pete, what are your views on this area?
Yeah, as George said, it certainly should be possible to sense the biomass of a crop of different crop species, including pulse crops, and that will be really useful for just sort of monitoring how they're growing and potentially what their yield potential is. So yeah, I think it's an important area.
Yeah, I mean,
very
I accept obviously that the technology is not in pulse crops at the moment, but I can see, I mean, we're learning through the NCS project just the scope of how we can improve returns from the pulse crop if you apply the agronomy a little bit better. And, this can certainly be a really useful tool as far as that's concerned, I can see. So now I can see that there's been some really interesting chat going on as well. And thank you to everyone who's taking part in that. I'm not going to try and summarize or re-ask questions.
There's one really important question, I think, in there, which is about if there's a dry spell of weather coming up and the implications for timing the nitrogen, because it's something that, I know that Messium have sort of agonized over, and I've sort of agonized over as well. And it's a really difficult question to answer. The question is basically if your crop looks like it's maybe taken a bit too much up, but then it looks like it's going to go dry, or there's a risk it's going to go dry. What do you do? Do you delay and risk it turning dry and then the crop doesn't take it up? And I think, George, you've got the sort of weather forecasting model built into that, and I think the model's going to take account of the weather forecast, and if it is going to be a very long dry period, I think you just have to sort of say, well, you're going to apply the nitrogen. It's better to do that rather than not apply it and delay, and then it never gets taken up until too late.
Correct. The weather is the hardest thing we deal with. The UK, for the most part, I mean, East Anglia can suffer from this, but for the most part, compared to somewhere like Australia, is actually very consistent. And so we have got a lot of experience in dealing with water limited yields from Australia. And basically the big problem there is, if it's going to rain more in your season, then put more nitrogen down. If it's not, don't put that nitrogen down. We understand the crop growth and the response if there is nitrogen. So if we could predict the weather perfectly, we can then work backwards and say, well, if there's this amount of rainfall, there's going to be this amount of biomass growth and therefore this nitrogen requirement. The difficulty is obviously predicting the weather. But with this supercomputer that we're using, we are looking for directional forecasts. So we're looking to understand, will the next month be wetter and colder than average, or will it be warmer and drier? And that can start getting us moving in the right direction, and therefore making a recommendation that should fit. Of course, the weather could do something completely unpredictable, but on average, we hope we're slightly more accurate.
No, thanks for that, George. Tom, did you want to come in on this at all?
I think it's a very good question, and I'm glad somebody asked it, because that's always our problem over here. But as I say, if it's going to be built into the decision engine, and that just sort of another factor in. But we all know how unreliable weather forecasts can be, so it's just yeah, we're still going to have some element of input into it, I guess.
Yeah, I mean, I must say the trials that you're doing in Australia, as you point out, George, you know, if we think we have problems with dryness here, you know, it's nothing compared to what they have over there, I'm sure. So that's really going to help inform things. But look, we've nearly come to the end of our time. Thank you. Oh, hang on a second. We've got another question, I think, that's come through.
Can we address the one that James Hart's put in there, Tom, about the variability? Because obviously we have only done a small plot trial last year, and it's a good point. If you're looking at timing and you've got a 20-hectare field, for example, and half of it says you want to put it on now and the other half says you've got to put it on in 2 weeks, that could be quite annoying. I don't know whether George has got any comeback on that.
Yeah, sorry, just have you seen that question? This is thank you very much, James. Is variability within plot areas suggesting micro variability or more macros, farm scale? I.e., is this going to produce a farm timing plan or field timing plan?
So operations and logistics are always key, and we need to factor that in. And so there is, you know, particularly again, if you look at the Australian example, when they've got 3,000 to 5,000 hectares that they need to get over, they will never be able to do each area perfectly. And so in these instances, we give the right recommendation for that time period, assuming all of the different variabilities. But it shouldn't be too extreme within a field.
Great. No, well, thank you very much, George. Listen, I'm going to bring the questions to an end now. Thank you so much for everyone who submitted to it. George, we'll come back on Eddie's question as well after the webinar. But before we go, I'd just like to bring up our poll again to see how we've moved on understanding and knowledge of hyperspectral monitoring. So please do take part in the poll. Let us know. Do you feel you know a little bit more about it now? Oh yeah, I think things are shifting. It looks that way. There's still one or two cheeky people who are saying I know nothing about it. That's ghastly. No, here we. Oh, we've even got a few hyperspectral experts on our hands, so that's fantastic. Let me just share the results. I'm not sure whether you can actually see them now. Has that come up on the screen all right? So there we go. We have moved things along a bit with hyperspectral mod. I have to say, I'm really enthused by what this technology can do. George, thank you so much to you for coming along to present it today, and also for supporting this webinar. And thank you very much to Pete and also to Tom for bringing your knowledge, your expansive knowledge, Pete, of this area, and also Tom, your experience with using the technology on your own farm. So George, I don't know whether you wanted to just say a couple of words before we disappear.
Yes, Tom, thank you so much for putting this together. I think it's been a brilliant event. Tom Dewars, thank you so much for your continued support, not just in trials this year, but with these things like webinars. Pete, thank you for your input again and continued support. And thank you everybody for joining. I hope it's been a really interesting session, and there's plenty of interest going forward. Have a fantastic day.
Well, while George was talking there, I was trying to get the contact details for Boffin up and spectacularly failed. But if you go to the website, www.boffin.org.uk, there's plenty on there for you to see. And please do, as I say, join our communities. Come to the NCS one in particular, the Pulse PEP. And if you'd like to carry on the conversation, do please bring it there and get the discussion going. I think this is a fascinating area. We'll hear more from it, I'm sure, as things go on. But thank you all very much for joining us. Thank you for your contributions in the chat and in the Q&A. We'll be sending out a link to the video of this in the next day or so as well. But if you've got any comments, then please do come back to myself or Sky or to Laura or Clemmy with any of your thoughts. I'm sure Pete and George would welcome your questions too. So thank you very much for joining us, and enjoy the rest of your day, and goodbye.